Good evening. Today we will be discussing voltage dividers and the voltage divider rule. Firstly, we will begin by dividing voltage. Voltage is defined by the equation V is equal to I times R, where I is the current and R is the resistance. Voltage divider is used to find the voltage across a resistance connected in a series circuit. Voltage divider circuits use resistors to reduce voltage. They can be used to do a lot of things like create a volume control circuit or generate reference voltages. If you have two resistors of different values, the voltage gets divided up in proportion to the amount of resistance there is. In this example to the right, with 20% of the resistance on the bottom, you get 20% of the input voltage on the output. The total voltage is shared between the resistors, depending on their values. So if R1 is equal to R2, then V1 is equal to V2, meaning that the resistors with the same values will have the same voltages. Using the example to the right, if the top resistance was 20 ohms, just like the bottom, then the voltage across both resistors would be 0.5 volts. Now we will be discussing how the voltage divider rule is applied in this example. Here we have 10 ohms across R1, 20 ohms across R3, and 5 ohms across R2. Using the equation Vx is equal to E multiplied by Rx over R total, we can find the voltages across each resistor. Step 1 is to calculate R total. To do so in a series circuit, you simply add them all up to find your sum. In this case, 35 ohms is our sum. The second step is to apply the equation for each resistor individually. First, we begin by finding V1 across R1. To do so, you multiply 70 volts times the resistance R1, which is 10 ohms, divided by the total 35 ohms to give you a value of 20 volts across R1. Finally, in step 3, you apply the equation for the rest of the resistors to find that V2 is equal to 10 volts and V3 is equal to 40 volts. Finally, we can confirm that this equation is valid, as if we add all the voltages calculated, we get 70 volts, which was our V input or E.